Okay. This is applications. Okay. Next we will go to the calculation of motional EMF shift. Okay. After that we will go to the application. Just basic concept I will explain. After that, okay, some formulas. Up to that you do the problems. Then after you come back to applications. What is motional EMF? What is motional EMF? Motional EMF. What we are doing in the motional EMF? Take a conductor of length L. Okay, this is length. And take small l, capital whatever it is. Okay, some books give capital. Okay. Now it is under the influence of magnetic field. We are applying a magnetic field like this. That is, take that as right. This length of the rod we are moving like this with a certain velocity. Understand? Okay, the length of the rod we taken and this rod we are moving in a magnetic field. What happens? What happens? Already previously discussed whenever you take a coil, the magnetic field is changing. What is happening? EMF is developing. Yes or no? Right? In this case, we are not passing any current. Understand? Just we taking the length of the conductor, just we are passing, just we are moving the length of the conductor in the magnetic field. Whenever the length of the conductor is moving in the magnetic field, what happens? EMF will be generated in the rod. That EMF which is generated in the rod due to motion of the conductor, that's motional EMF. Understand? Clear? So why this EMF generated? That is a discussion, small, and we can go formula directly. Okay? So you know that the rod consisting of number of atoms, which consisting of number of charges. Yes or no? Which positive and negative charges. Yes or no? So according to that, the charge which is there, okay, whenever it is moving with velocity, whenever it is moving with a velocity, the charges also moving with velocity. When the charges are moving with a velocity in the magnetic field, what happens? Experiences a force. Understand? Now, in this case, okay, what is the direction of the force on that charges? Okay, if you take the negative charge, okay, there is electrons. If you take the positive charge, there is positive charge. Here, the electrons experiences a force. Electrons experience a force. That electrons which are in the conductor, that will be moves towards the downward direction. Understand? So, whenever the conductor of length L moving with a velocity, the charges inside the conductor also moving with a velocity in the magnetic field. That's why these charges experience a force. Whenever the forces are acting, then negative charges will be experience the force in one direction, positive charges will be experience the force opposite direction. Understand? So after some time, what is happens? Completely this end becomes negative polarity and this end becomes positive polarity. Means this becomes positive potential, negative potential. More electrons, negative, less electrons, nothing but positive. Electrons is moving, so electrons are expensive force will move towards the electrons. Understand? So that means this rod, okay, we can replace with simply a construction of battery. Understand? Here, it's symbolically replaced with this. That means this rod is nothing but it acts like a positive battery. So this is nothing but battery which provides the EMF. Whenever the EMF generates, what happens? Generates a current when it is connected to the circuit. Understand? Suppose this rod is connected with some arrangement, okay, some other wires, okay, of this like this. These are non-resistive. This is the resistance R. Whenever this battery, this movable conductor is connected to the resistance like this, then what happens? There is a current exists. What is the direction of the current? Positive to negative. This is the direction of the current which exists. So the concept says what direction the current will flow. You have to understand. Now what the current exists in the what is the current in the circuit? I is equal to nothing but V by R. Okay, that is nothing but E by R. What is E value here? EMF, motional EMF. Understand? That E is nothing but motional EMF. That motional EMF value, how to calculate here? The motional EMF E is equal to nothing but BLV is the formula of that. What is that? BLV. Depends on the strength of the magnetic field, length of the conductor, and velocity. Is it okay? So that means what is B? Magnetic field L, V. Three are vectors or scalars. B is the magnetic field vector, L is the vector, V is the vector. Three are vector now. So the EMF generated in the motional condition, that means any rod which is moving the magnetic field depends on, that is one. Okay, that is B cross L cross V. One. Okay, and second one EMF we can write that is L cross V cross V. The third one is equal to what is that? V cross L cross V. This is the link. Clear. So the main point in this you need to understand is accumulation of charge. One. Second, EMF when it is going to generate, based on the number of applications and exams in the competitive they will ask. Okay. So what you understand here? When the conductor is moving towards the right, magnetic field into the board, then EMF direction is, what is the EMF direction? That means above point acts like a positive, below point acts like a negative. That you have to remember blindly. Understand? Suppose the magnetic field direction changes, automatically force direction changes. In that case, electrons will experience a force upward direction. Understand? Clear? So that means direction of the current also changes. What happened? Upward direction it will flow like that. Is it okay? Now when that EMF means that potential difference rod when it is connected to any circuit, there will be current across that one. What is the current value? I is equal to V by R. Okay, what is the potential? The potential, which potential? Motional EMF. What is the motional EMF formula? VL. That depends on the strength of the magnetic field, length of that one, velocity of that one. Understand? What is our resistance? If the circuit consisting of one resistor, only R. If the circuit consisting of number of resistance, total resistance you have to take. That is the concept. Is it okay? Shall I go next? Now, this is over. Next, another point you have to remember in this case is, okay, if you want to get EMF, what is the condition for length, velocity and magnetic field? Suppose the rod is moving like this. Magnetic field we are applying like this, rod is moving like this. There is any EMF existing in this rod? There is any magnetic field in this? తక్కువ రైల్సీడ్ ఎక్కువ. ఎంత క్లియర్గా రికార్డ్ అవుతుంది తెలుసు దాంట్లో మన వాయిస్ కన్నా ఆ వాయిస్ ఎక్కువ రికార్డ్ అవుతుంది. Okay, no. So when we are going to apply this EMF, okay, so I asked the question now. What is the question asked? When the conductor is moving like this, magnetic field applied like this, EMF generating this or not? That is one thing you need to understand. Okay, now rod is falling like this. Understanding? Magnetic field is okay applied like this. EMF generated or not? Magnetic field applied like this, rod is falling like this. EMF generated or not? In this case, yes. Okay, what is the difference? That is only you need to understand. If you understand that, we can close this. Okay. Okay, first point is BLV, they are vectors. If the EMF has to generate in the rod or moving conductor, means compulsory the B value, L value, V value must be perpendicular to each other only. If any two are parallel to each other, then EMF will not generate. Blindly you can do. Understanding? B, L, V, three must be perpendicular to each other. That means if you come across here, if the rod is moving like this, magnetic field you are applying like this. Magnetic field perpendicular to length of the rod. Okay, rod is moving like this means what is the direction of the velocity? Upwards. What is the direction of the length? Upwards. Both are these two are parallel means no EMF. Understood? Now rod is falling. We are applying the magnetic field like this. Rod is falling like this. In this case, magnetic field and this length perpendicular and velocity perpendicular. So EMF generates. What that point? Very important point. You need to understand. I mean everything is small. Okay. Now aeroplane is moving in the air under the earth magnetic field BH. Understand? So earth magnetic field BH means. So what is the EMF generating this? Due to horizontal earth magnetic field EMF generates. Airplane moving in the sky, there is any EMF generated in the wings. You know the wings. Okay, this is airplane, this is the wings. Okay, this is made up of the metals conductors. Yes or no? So when they are moving in the earth magnetic field, is that EMF generates across the ends of the conductor? Understand why? Because earth magnetic horizontal magnetic field is like this. Airplane also moving in the same magnetic field. That's why both are parallel. So no magnetic field. But there is a EMF exists across the ends due to vertical magnetic field. Yes sir. What is earth magnetic field? It is a combination of horizontal magnetic field and vertical magnetic field. So what is the vertical magnetic field? The vertical magnetic field is equal to nothing but BB. Yes or no? BH is the horizontal magnetic field. BB is the vertical magnetic field. So vertical magnetic field is upwards. The length of the wings of the airplane is like this. Airplane velocity is like this. Three are perpendicular. So there is a EMF across the ends of the wings. Okay. So they ask the competitive question by giving the B value across the horizontal or vertical. So you have decided that if it is horizontal, B value is 0. E value is 0. Sorry. If it is vertical, E value exists. Then you have to calculate. Is it okay? Then we have to follow which method? Cross product. So this will be asked in the IIT, okay, mains and advanced levels also. Advanced level means they give the vector forms of all, and they you need to calculate in terms of cross products. That's it. In the combination, they will ask in combination method. Enough? That's it. This is enough. Okay. Draw a diagram and you try to answer that question and you copy. Shall I erase this one? Yes. question. This is one of the rod of length here. Right? Now, this is one of the R. Calculate the current in the circuit. Okay, so just concept I will explain, later we'll do the problems. This is the length of the conductor. Now, this total arrangement is moving towards right with velocity, and we are applying the magnetic field onto this into the book, that is B. Now, what is the motion EMF generating this? This is the resistor, not the wire. This is the length of the wire which you take. These are the resistors arranged in the Wheatstone bridge form. Okay. What is the current in this circuit? So according to basic concept, current is equal to E by R, nothing but E by R. E means which EMF you have take? Motional EMF. That motional EMF is equal to nothing but B into L into V by R. Yes or no? Right. So in this case, what is B applied magnetic field? What is L length of this one? What is B velocity? Okay, that's all. What is R resistance? How many resistors? Only one resistor means you can take this. 1, 2, 3, 4, 5 resistors are there. How can you take effective resistance? How to take effective resistance of this one? Wheatstone bridge, you can solve it. Okay. In this case, we can say here, no need to take Wheatstone. It is directly these two are connected in series, these two are connected in series. Then after these two are parallel. Effective you get. Okay. Now next, this one and this one, how they are connected? Series. Sure. Parallel. How can you say that? Just fold it like a book. You fold it like a book. What happens? This length L will be there, and this is Wheatstone bridge resistor. This actual resistor. Both are parallel to each other. Parallel to each other means that apply parallel combination. That means I can write here simply R effective you will take. So I is equal simply that is BLV by R effective value. What I can take? R into R effective. Yes or no? R into R effective by R plus R effective. R effective means which R effective you have to take? This is R effective value of this one. Like that you have to solve the problems. And these concepts. So I will give some problems, okay, tomorrow, and you can solve. That's the topic is almost only problems you have to do different problems. Okay. So we close.